Today we are very interested in finding out the relationship between the number of moles of a gas and its volume. But before that, we would like to think about some parameters of a gas. A gas would have volume, pressure, and temperature. If I have a container and all the gas particle, when they are situated at a certain position from each other, so if you increase the temperature, they would have more energy to expand themselves or stay away from each other. They will move further away from each other, so you might see some gases actually starts to go up. This is what we call an increase in volume when you increase the temperature. When you increase the temperature, the volume will increase. So if you cool it down, if you decrease the temperature, the gas particles or the atoms, they will be closer to each other, so the volume is smaller. Alright, so this is what we call temperature dependent, because temperature actually affects the volume. So this is called volume directly proportional with temperature, not perpendicular, right? So when you have higher temperature, so the gas expands, so the volume increase. What about pressure and temperature? Pressure and volume, sorry. So this pressure and volume, imagine if you have a piston chamber. So this, you push the piston, okay, all the gases will be compressed, so the volume will cut down if you increase the pressure. Okay, you press down with more pressure. Okay, if you lift it up, they'll have more space with each other. So when the pressure decrease, the volume increase. Alright, so for gas, for all types of gas, as long as they are at the same temperature and pressure, okay, let's just say that they have the same temperature and pressure, the volume occupied by the gas will be the same in one container to another container, even though two containers having different gases. Okay, let me draw two containers at the same temperature and pressure. The volume is the same. Okay, the volume of 1 mole of gas, 1 mole of any gas. Alright, so let's try to find out this. Okay, you have 1 mole of any gas, so the volume occupied here will be the same. Volume here and volume here is equal, even though here I use nitrogen gas and I use oxygen gas. Right? So we have two different rules. Okay, the first rule is at room temperature. They set room temperature as 25 Celsius and atmospheric 1 pressure, 1 atmospheric. Okay, so the volume occupied, the actual volume occupied by 1 mole of gas would be 24 dm cube. Okay, so if you have 1 mole of gas, 1 mole of gas means you have 6.02 times 10 power of 23 let's use atom as an example. So all these atoms, gas particle, they will occupy 24 dm cube. Okay, so we come up with a general formula. So VRT, I'll just put 24 times number of mole. Okay, I'll show you some example. 3.2 mole of certain gas, okay, of nitrogen gas. At room temperature. So I'm interested to find out the actual volume, so I use 24 times 3.2 based on this formula. Alright, so 24 times 3.2, that will give you a value of, well, you can press with your calculator, and the answer is 24 times 3.2. That will give you 76.8. 76.8 dm cube. Another rules will be at standard temperature and pressure. They call it STP. Okay, standard temperature is actually 0 Celsius. Alright, pressure of 1 atmosphere. The volume occupied by a gas, if you have 1 mole of gas, it will occupy a volume of 22.4 dm cube. So the general formula that we can get is this: standard temperature and pressure, and we put 22.4 times number of mole. Right? So this is what we call molar volume, right? So 24 or 22.4 is are known as molar volume, the volume of a 1 mole gas. Okay, this is the convention or the rules that is set forward for us, and we can try some example of this STP. Example would be calculate the volume of they want you to calculate the volume, the actual volume of 0.78 mole of nitrogen gas, of oxygen gas. Alright, what type of gas they are is not really important, as long as we can get the number of mole. Alright, so at standard temperature, pressure. So what you do, you just write this, and then you put forward 22.4 times 0.78, and your final answer should be 17.5, right? 17.5 dm cube. Okay.